Okay, today's lesson is on what I call basic inequalities. We're going to graph inequalities. We're going to write graphs based on number lines. We're going to solve 1- and 2-step inequalities and graph the solution. So how do I solve and graph basic inequalities? Okay, an inequality is one variable, or the graph of an inequality in one variable is the set of points on a number line that represent the solution to the inequality. The big difference between inequalities and equations have one answer. Inequalities have infinite number of answers. It's a range idea. On graphs, open circles represent greater than and less than, and closed circles are used for greater than, equal to, and less than equal to. So let's look at the first one here we're trying to graph. X is greater than 5. So I want an open circle at 5. And then I want you to take a look here at this greater than sign. It actually forms my arrowhead pointing me up the number line so that I draw my arrow going up the number line. Every number bigger than 5 is a solution to this inequality. Okay, for the next one, I want to put a closed circle at 7 because of this equal to part of the symbol. And when I look at this symbol, it's an arrow pointing me down. Now this arrow trick that I'm using only works if your X is written first. If you have the number written first, this trick does not work for graphing inequalities. Let's look at a 1-step inequality. I need to subtract 4 from both sides, and X is less than 6. That's going to be an open dot, and less than is my arrowhead pointing me down. There we go. For the next one, I need to multiply both sides by -3. And when you multiply or divide by a negative number, you have to flip the sign. So I have X is less than or equal to -3. It's going to be a closed dot because of the or equal to part. And I'm being pointed down for less than. Look at the next one. I need to add 4 to both sides. X is less than or equal to -1. So a closed dot at -1. And my arrow is pointing me down. For the last one here, I need to divide both sides by -2. And when you divide by a negative, you flip the sign over. So X is greater than -4. Open dot at -4, and my arrow will be going up for greater than. So remember, when you multiply or divide by a negative number, you have to flip the inequality sign. Let's do one that's a little harder. Here's a 2-step. Okay, so I'm going to subtract 1 from both sides. 2x is less than 6. Then I'm going to divide by 2. Now this time I divide it by a positive, so I do not flip the sign. X will be less than 3. That's an open dot, arrow coming down. Okay, we solve these the same way we solve equations, except for the flipping when we multiply or divide by a negative. Oh my, I need to take care of this 3 squared first. So 2 minus 3x is greater than or equal to 5 minus 9. Move my variables to the left. See, damn it. 2 minus 8x is greater than or equal to negative 9. Move the 2 to the right. Negative 8x greater than or equal to negative 11. Divide by negative 8. Wow. X, I have to flip the sign, is less than or equal to 11/8. Yuck. 11/8. That's almost but not quite 2. So I'm going to put my closed dot here between the 1 and the 2, and my arrowhead's coming down. Next one. Ooh, let's get rid of this 4 on the denominator. Multiply both sides by 4 to get rid of that. So I have 3x minus 1 is greater than 12. Add the 1. 3x is greater than 13, and divide by 3. X is greater than 13/3. That's 4 1/3. So an open dot here between 4 and 5. And in this case, my arrow is going up. A solution to the inequality has to make the inequality true. And all we want to do in this situation is substitute the value for x and see if it's true. So 2 times negative 3 plus 1 has to be greater than 3 for this to be true. Negative 6 plus 1 greater than 3. Negative 5 greater than 3. That's not true. Negative 5 is less than 3, so it doesn't work. Let's try 2 times negative 1 plus 1 greater than 3. Negative 2 plus 1 greater than 3. Negative 1 greater than 3. Oh my, this doesn't work either. These are both no's. Okay, let's try some other numbers. Let's see. 13 minus 7 times negative 1 less than or equal to 6. So 13 plus 7 less than or equal to 6. 20 less than or equal to 6. No. 13 minus 7 times 0 less than or equal to 6. 13 minus 0. 13 less than or equal to 6. Another no. Get there eventually. Let's see. 13 minus 7 times 1 less than or equal to 6. 13 minus 7 less than or equal to 6. 6 less than or equal to 6. Yes, it's not less than, but it is equal, so this is a yes. Not one of them. Let's see if the other one works. 13 minus 7 times 3 less than or equal to 6. 13 minus 21. And let's see, that's going to be negative 8 less than or equal to 6. That's also true. So we had a couple no's, we had a couple yeses. The thing about inequalities is you have to check every single number when you're asked if it's a solution. And you're at your summary. So take a few minutes to write summaries of questions.